The moon, our celestial neighbor, eternally etched in our night sky. For millennia, it has been a source of wonder, inspiring countless myths and legends. Yet beneath its desolate beauty lies a secret. This secret has the potential to redefine our future in space. It's something far simpler, yet profoundly significant. Water. Deep within its polar regions, hidden within craters cloaked in perpetual shadow, lies water ice. This discovery, confirmed by NASA, has sent shockwaves through the scientific community. It's a game changer, one that could rewrite the rules of space exploration, providing drinking water, oxygen, and even fuel. This is not science fiction, it's the tantalizing potential of lunar water. The discovery of water on the moon didn't happen overnight. Years of meticulous research and cutting-edge technology led to this revelation. The LRO and Diviner instruments were pivotal. The LRO, launched in 2009, mapped the lunar surface. Its cameras revealed features hinting at water ice. The Diviner measured surface temperatures, detecting ice. Combined data painted a compelling picture of hidden water. This discovery raises more questions than it answers. How can we utilize this resource to further our space ambitions? Water is often referred to as the elixir of life. In space, it becomes a critical resource for exploration. The discovery of water on the moon is a game changer. Imagine lunar bases using the moon's own resources. Water can be split into hydrogen and oxygen, the building blocks of rocket fuel. This enables longer, more ambitious missions, unlocking a new era of space travel. The discovery of water on the moon wasn't a serendipitous event. It was the culmination of meticulous planning, cutting-edge technology, and the dedication of countless scientists and engineers. While telescopes had long hinted at the possibility, it was NASA's sophisticated instruments, specifically designed to probe the moon's mysteries, that provided the definitive proof. Two instruments stand out as pivotal players in this scientific revelation: the Lunar Reconnaissance Orbiter, LRO, and the Diviner Lunar Radiometer Experiment. These technological marvels, orbiting our celestial neighbor, have revolutionized our understanding of the moon, revealing it to be a far more dynamic and resource-rich world than previously imagined. The LRO, with its keen eye and suite of advanced sensors, has been tirelessly mapping the lunar surface, providing a level of detail previously unattainable. Its images, captured from orbit, have revealed the moon's rugged beauty in unprecedented clarity, showcasing its towering mountains, vast plains, and the intriguing shadowed craters where water ice lies hidden. Complementing the LRO's visual prowess is the Diviner, an instrument that delves beneath the surface, sensing the moon's temperature with remarkable precision. Its data, a symphony of heat signatures, have helped scientists identify areas where the moon's frigid cold hints at the presence of water ice, hidden from the sun's relentless rays. The Lunar Reconnaissance Orbiter, or LRO, is a sophisticated robotic explorer, tirelessly circling the moon and transmitting data back to Earth. Launched in 2009, the LRO has become indispensable for lunar scientists. Equipped with 7 powerful instruments, it maps the lunar surface in exquisite detail. Its cameras capture stunning images of the moon's diverse landscape. One key objective is searching for water ice, vital for future human exploration. Section 3. The Diviner's Eye. Sensing the moon's hidden depths. The Diviner Lunar Radiometer. Experiment senses the moon's temperature to uncover hidden secrets beneath its dusty exterior. This instrument has provided invaluable insights into the Moon's thermal environment, revealing crucial clues about its composition and history. The diviner measures the infrared radiation emitted by the lunar surface. Different materials emit infrared radiation at different wavelengths, creating a unique thermal fingerprint. By analyzing these emissions, scientists can identify minerals, rocks, and even water ice. The diviner confirmed extremely cold temperatures within permanently shadowed craters at the Moon's poles. These frigid regions act as cold traps, preserving volatile compounds like water ice. The diviner's data, combined with LRO images, provide compelling evidence for water ice deposits at the lunar poles. These deposits could be a game changer for future human exploration, providing water, oxygen, and rocket fuel. Section 4. Beyond the visible. How instruments see the unseen. The human eye perceives only a tiny fraction of the electromagnetic spectrum. Instruments like the Lunar Reconnaissance Orbiter and Diviner reveal hidden wonders. The Diviner detects infrared radiation, creating detailed temperature maps of the Moon. It distinguishes rocks and minerals and confirms water ice deposits in shadowed craters. Piecing together the lunar water puzzle. The discovery of water on the Moon was the result of years of meticulous data collection and analysis. The LRO and Diviner provided crucial data, painting a picture of a dynamic, resource-rich Moon. LRO's high-resolution images revealed initial clues. Its cameras found features hinting at water ice in shadowed craters. Diviner confirmed these craters were cold enough to preserve water ice. Combined data painted a compelling picture of hidden water ice deposits. Section 1. Lunar water. A tale of two forms. The discovery of water on the Moon wasn't just a single revelation. It was the unveiling of a resource that exists in multiple forms. Lunar water exists as both ice and vapor, each presenting unique challenges and opportunities. Ice is found in permanently shadowed craters, shielded from the sun's heat. Water vapor is far more elusive, a wisp of mystery in the lunar void. Understanding these forms is crucial for future missions. Section 2. Ice. A frozen legacy in the lunar shadows. In the depths of permanently shadowed craters, where sunlight has never ventured, lies a frozen legacy water ice. This ice, a relic of billions of years, represents a potential game changer for lunar exploration, offering a readily accessible source of water for drinking, oxygen for breathing, and even fuel for rockets. These permanently shadowed craters, often located at the poles, act as natural cold traps. Temperatures within these craters plummet to unimaginable depths, far colder than any place on Earth. This extreme cold, coupled with the lack of sunlight, creates an environment where water ice can persist for eons, shielded from the harsh conditions of the lunar surface. The evidence for water ice in these craters comes from a variety of sources. Instruments aboard orbiting spacecraft, such as NASA's Lunar Reconnaissance Orbiter, have detected the distinctive spectral signature of water ice, confirming its presence beyond doubt. This ice, however, isn't a pristine solid mass. It's likely mixed with lunar regolith, the fine powdery dust that covers the moon's surface. This mixture, while potentially challenging to extract and purify, still represents a valuable resource, one that could sustain human presence on the moon for generations to come. Section 3. Vapor, a wisp of mystery in the lunar void. While water ice captures the imagination with its potential as a readily available resource, water vapor on the moon presents a more enigmatic challenge. Existing in minute quantities, it dances across the lunar surface, a wisp of mystery in the lunar void, hinting at a dynamic water cycle we are only beginning to understand. Unlike the ice trapped in permanently shadowed craters, water vapor is constantly on the move, interacting with the lunar environment in complex ways. It can be released from the lunar surface through a process called desorption, where water molecules, loosely bound to the soil, are liberated by solar radiation or micrometeoroid impacts. Once liberated, these water molecules embark on a journey across the lunar surface, hopping from one location to another, driven by temperature variations and the moon's weak gravity. Some of these molecules eventually escape into space, lost to the void, while others find their way to the permanently shadowed craters, where they freeze and contribute to the ice deposits. Understanding the lunar water cycle and the role of water vapor within it is crucial for understanding the moon's history and its potential for sustaining life. It's a puzzle that scientists are only beginning to piece together, with each new discovery raising more questions than answers. Section 4. Mapping the molecular bounty. Locating lunar water. The discovery of water on the moon has ignited a new era of lunar exploration. Advanced instruments reveal the moon's watery secrets. Spectroscopy identifies water ice and vapor. Water ice confirmed in shadowed craters. Neutron spectrometry detects hidden water. Mapping lunar water unravels the moon's history. Section 5. Craters of Promise. Unveiling the moon's watery vaults. The permanently shadowed craters at the moon's poles have emerged as focal points of interest in the quest for lunar water. These craters, shrouded in perpetual darkness, offer a glimpse into the moon's distant past, preserving volatile compounds like water ice that would otherwise be lost to the harshness of space. These craters, some of them billions of years old, have acted as natural cold traps, collecting water ice delivered by comets, asteroids, and even the solar wind. Shielded from the sun's heat and the vacuum of space, the ice within these craters represents a potential treasure trove for future lunar explorers. Accessing these icy vaults, however, presents a unique set of challenges. The extreme cold, lack of sunlight, and rugged terrain make these craters forbidding environments, even for robotic explorers. Nevertheless, space agencies around the world are developing missions to explore these craters, using rovers equipped with drills, scoops, and instruments to characterize the ice deposits and assess their potential as a resource. These missions, daring in their scope and ambition, represent the next chapter in lunar exploration. They hold the promise of unlocking the secrets of the moon's watery past and paving the way for a future where humans can live and work on the moon, sustained by the resources of our celestial neighbor. The discovery of water on the moon wasn't just a scientific curiosity, it was a paradigm shift. It ignited a new era of ambition in space exploration. Water, the elixir of life, is crucial in space travel. It's a source of oxygen, radiation shield, and potential fuel. The moon becomes a launching pad, a stepping stone to the cosmos. Water, often taken for granted on our water-rich planet, becomes a precious commodity in the unforgiving environment of space. For astronauts living and working beyond Earth, access to water is paramount, not just for their physical well-being, but for the viability of long-duration missions and the establishment of permanent outposts. The discovery of water on the moon offers a solution, a lifeline for future lunar inhabitants, extracted from the lunar surface, whether from ice deposits in permanently shadowed craters or vapor captured from the tenuous lunar atmosphere. Water can be transformed from a simple molecule into the lifeblood of a lunar settlement. Purified lunar water could quench the thirst of astronauts, providing a vital component of their daily sustenance. Electrolysis, a process that uses electricity to split water molecules into hydrogen and oxygen, can generate breathable oxygen, ensuring a continuous supply of this essential element for life support systems within lunar habitats. But the potential of lunar water extends beyond basic survival needs. It can be used to create hydroponic gardens, where plants can thrive in a controlled environment, providing astronauts with fresh food and enriching their diet with essential vitamins and minerals. Water, in this context, becomes more than just a resource. It becomes a symbol of self-sufficiency, a testament to humanity's ability to adapt and thrive in even the most challenging of environments. As we set our sights on more ambitious space missions, venturing further from Earth and staying longer, the challenge of transporting fuel becomes increasingly daunting. Launching propellant from Earth is a costly and complex endeavor, limiting the scope and duration of space exploration. Lunar water, however, offers a tantalizing solution, the potential to transform the moon into a cosmic gas station. Water, when split into its constituent elements, hydrogen and oxygen, becomes a potent rocket propellant. Liquid hydrogen and liquid oxygen, when combined in a rocket engine, produce an immense thrust, propelling spacecraft to incredible speeds. This same chemical reaction, harnessed for centuries in various forms, could power humanity's journey into the cosmos. Imagine lunar fueling stations, strategically positioned on the lunar surface, extracting water from the moon's resources and converting it into rocket propellant. Spacecraft, instead of lugging all their fuel from Earth, could make a pit stop at these lunar outposts, refueling with locally sourced propellant and venturing further into the solar system. This paradigm shift in space logistics could dramatically reduce the cost and complexity of deep space missions. It could enable longer, more ambitious expeditions, allowing us to explore the moons of Jupiter and Saturn, venture to asteroids, and even contemplate manned missions to Mars, all fueled by the humble water molecule, transformed into a cosmic powerhouse. Section 4. Beyond the Moon. A stepping stone to Mars and the solar system. The discovery of water on the moon has implications that extend far beyond our celestial neighbor. It has the potential to reshape our entire approach to space exploration, transforming the moon from a destination in itself to a stepping stone, a launching pad for humanity's journey into the cosmos. With access to water, the moon could become a hub for spacecraft assembly and launch, a forward operating base for missions to Mars and beyond. Imagine spacecraft components manufactured on Earth being transported to the moon for final assembly. utilizing the moon's lower gravity and lack of atmosphere to reduce costs and complexity. Lunar water, converted into rocket propellant, could fuel these deep space missions, reducing our reliance on Earth-based launches and enabling longer, more ambitious expeditions. The moon, in this scenario, becomes a critical link in a chain of infrastructure connecting Earth to the rest of the solar system. Furthermore, the moon offers an ideal environment for testing and refining technologies that will be crucial for future human missions to Mars and beyond. Life support systems, radiation shielding, and in situ resource utilization techniques can be tested and perfected in the moon's challenging environment, providing valuable lessons for future explorers venturing further into the cosmos. Designing for a water-rich moon. The discovery of water on the moon has ignited the imaginations of architects and designers. Lunar architecture is now grounded in the reality of resource availability. Water enables architects to envision thriving, self-sufficient lunar settlements. Imagine habitats shielded from radiation and temperature extremes. These habitats could incorporate hydroponic gardens and algae farms. Water shapes the design and functionality of lunar habitats. Water recycling systems and ice walls will shape lunar settlements. This new era of space architecture is driven by sustainability and innovation. Lunar water, a catalyst for global unity in space. The discovery of water on the moon reshapes our understanding and redefines space exploration. It urges nations to unite for peaceful and sustainable space exploration. Space exploration was once driven by competition and national pride. Lunar water offers a chance to rewrite this narrative. It brings nations together in collaboration and shared ambition. Unity in space is a pragmatic necessity. Cooperation, not competition. The discovery of lunar water has reignited the spirit of the space race, but this time the rules have changed. The new space race is a race to cooperate, to pool resources, and to work together towards a common goal. This shift is driven by the recognition that the challenges of space exploration are too great for any one nation alone. Nations with a history of rivalry are now exploring partnerships, recognizing that by working together they can achieve far more. Section 3. Sharing the lunar bounty towards an international framework for resource utilization. The discovery of water on the moon raises complex questions about resource rights, ownership, and ethical implications. As nations and private companies eye the moon's resources, a clear international framework becomes urgent. The 1967 Outer Space Treaty declares space as the province of all mankind, but is vague on resource extraction. Proposals range from an international lunar authority to resource allocation based on scientific or technological contributions. Balancing national interests, commercial aspirations, and responsible stewardship of the moon is crucial. Section 4. From Rivals to Partners, the transforming power of shared ambitions. Space exploration has often been marked by competition, but lunar water could transform rivals into partners. The challenges of space exploration demand a global effort, pooling resources, and expertise. Lunar water, with its potential to fuel spacecraft and sustain life, is a catalyst for this transformation. Nations are now exploring partnerships, recognizing the benefits of collaboration. The International Space Station exemplifies the power of international cooperation in space exploration. The discovery of water on the moon is a call for unity in space exploration. The challenges of space exploration demand a global response, transcending political boundaries. Lunar water symbolizes unity, reminding us of our shared destiny and responsibility. The future of humanity depends on our ability to work together in space exploration. The discovery of lunar water is a call to action for a new era of united space exploration. It's an invitation to embark on a shared vision for a brighter future among the stars. The discovery of water on the moon challenges our understanding of its formation and evolution. Water, especially in ice form, hints at a more dynamic past than previously imagined. The moon was once seen as a dry, desolate world, but water forces a re-evaluation of its history. One theory suggests water arrived via comets and asteroids billions of years ago. This discovery opens up possibilities for rewriting the moon's history. Scientists now consider alternative scenarios for how water ended up on the moon. The presence of water on the moon raises questions about its origins. Did water play a role in the moon's formation, or did it arrive later? One theory suggests the moon formed from debris after a giant impact with Earth. Recent studies suggest some water could have survived the impact or arrived later. Water could have influenced the moon's internal structure and evolution. Understanding water's role is crucial for unraveling the moon's geological history. Section 3. A time capsule of cosmic history. What lunar ice can reveal. Lunar ice is a time capsule preserving billions of years of cosmic history. Studying its composition can reveal insights into the early solar system. Lunar ice has remained undisturbed, making it an invaluable archive. Isotopic composition can determine the origin of the moon's water. Ice layers provide a timeline of impacts, shedding light on the history of the inner solar system. Section 4. Water on the Moon, Life on Mars, the broader implications. The discovery of water on the moon influences our understanding of life elsewhere. It raises questions about similar reservoirs on other airless bodies. These reservoirs could be valuable resources for future explorers. Lunar water provides a valuable analog for understanding life on Mars. Techniques developed for lunar water detection will aid in the search for life beyond Earth. Section 5. Redefining habitability. Lunar water and the search for life beyond Earth. The discovery of water on the moon challenges our definition of habitability. It suggests habitable environments could exist outside the traditional habitable zone. The subsurface environment of the moon could offer a more hospitable refuge. The presence of water ice suggests the potential for microbial life. If life exists in these extreme environments, it would have profound implications for our understanding of habitability. Section 1. The moon's call to adventure. The discovery of water on the moon is a call to embark on a new era of exploration. It reveals the moon as a potential treasure trove of resources, Water transforms the moon into a partner in humanity's quest to explore the cosmos. The moon offers a chance to establish a sustainable human presence beyond Earth. It's an invitation to push the boundaries of human ingenuity and embrace the unknown. A universe of possibilities. The discovery of water on the moon has opened up a universe of possibilities, fundamentally altering our perspective on space exploration. It challenges us to envision a future where humanity becomes a truly spacefaring civilization. Imagine lunar bases evolving into thriving settlements, powered by the moon's resources. Lunar pioneers would push the boundaries of human knowledge, conducting groundbreaking research. The moon could become a hub of activity, a bustling center of commerce and industry. Lunar ice could provide rocket propellant, fueling missions to Mars and beyond. This discovery speaks to a deeper truth, a shift in our understanding of our place in the cosmos. Section 3. Our future among the stars. The discovery of water on the moon is a gift, a legacy for future generations. It challenges us to think beyond the immediate and ensure our exploration is guided by sustainability and cooperation. As we stand at the cusp of this new era, it's imperative we proceed with a sense of shared purpose. The moon, with its newfound bounty of water, is a shared resource that has the potential to unite us. Imagine a future where children dream of living among its craters and exploring its hidden depths. This is the future that the discovery of water on the moon has made possible. Let us embrace this future with open minds and courageous hearts.